In this first example of taking the derivative of a linear function using the limit definition, we already know the answer to the question in advance. That is, we know that the slope of a linear function is just the m in mx plus b format. So for this function f of x is equal to 2x minus 3, we should expect to find that the derivative is 2 because the slope of this straight line is 2 everywhere on it. So I've written down the definition for us here. The derivative f prime of x is equal to the limit as delta x approaches 0 of that secant line formula that we have, slope of a secant line, f of x plus delta x minus f of x divided by delta x. So if we plug in here, we're going to have the limit as delta x approaches 0 of 2 times x plus delta x minus 3. I'm going to put that in some brackets. Then we're going to subtract f of x, which is 2x minus 3, and we will divide all of that by delta x. Removing parentheses in the numerator, we'll get the limit as delta x approaches 0 of 2x plus 2 delta x minus 3 minus 2x plus 3, all divided by delta x. Now, in the numerator, we see that some things are going to add to 0. So we're going to have the limit as delta x approaches 0 of 2 delta x. And everything else goes away. We have a positive 2x and a negative 2x. We have a negative 3 and a positive 3. That's all that survives. That's still over delta x. But now we have a delta x as a factor, numerator and denominator. So this is the same thing as the limit as delta x approaches 0 of just 2. That is after we cancel those delta x's. And the limit of a constant is just that number. So f prime of x is equal to 2, exactly the result that we expected to get.